Welcome to 3D Flow Academy. This tutorial is focused on control points usage and still requires Zephyr Pro or Aerial. Look up the previous episode for the first part of this video tutorial. One of the simpler yet very useful control points application is the workspace merge action. In order to merge two different workspaces, you can simply define the same control points in two different ZEP files. This requires a certain overlap between the two workspaces. Save one of the ZEP files, in this example 2.zep, and close Zephyr. Open the other ZEP file, in this example 1.zep, and drag and drop the previous workspace 2.zep over the active Zephyr window. Use the merge option and then proceed using control points. If control points with the same name are available in both workspaces, Zephyr will automatically add them to the pairing list. Make sure that the correspondence is correct, or add your own pairs if the control points have different names or the names do not match. Depending on your dataset, you may want to enable an additional bundle adjustment step. In this case, I'm doing a simple merge. The new workspace containing both projects can now be saved and used normally. Note how control points are now joined and how the sparse point cloud has been joined too, while other components have not. In most cases, you'll want to merge workspaces after the sparse point cloud phase so that you can generate one new dense cloud with all the camera's information. However, in some cases, it's useful to generate different, smaller dense point clouds and merge them together after workspace merge. Other merge options are usually used with georeference data or by having Zephyr looking at the camera neighborhood. Let's quickly have a look at them. Merging using same reference system will simply merge the two files. If the reference system has been set up correctly, either via control points constraint or camera constraints, no additional operations are required. Merging using nearby cameras will start an additional matching phase. Hold down the left control key while left-clicking to select multiple elements and select cameras from the first workspace that are close to the second workspace cameras, and let Zephyr do the work. Please note, however, that in big dataset this operation may take a while. A very similar operation can be done to add new photos to an existing workspace. Simply select Add Photos from the workflow menu and proceed. Please note, however, that in order to successfully add photos with this tool, the nearby cameras must have the same internal parameters as those already in the workspace. Another useful control points application is the manual camera orientation. Let's say one or more photos couldn't get oriented by Zephyr. You could remove the non-oriented camera in the workspace and then force Zephyr to add the photo by manually defining common control points. Please note, however, that this process is completely manual and that the accuracy of the camera placement is directly influenced by how accurate you are when picking control points. While the bare minimum is 3 control points, it's highly recommended that you pick a few more. Last time we introduced Zephyr's automatic marker detection feature, so let's take a more detailed look at it. You can print markers that Zephyr can automatically detect in your photos using the tool's control points print markers function. A PDF file will be generated for you. Always print markers at an appropriate size, depending on your dataset. A4 or A5 papers are fine for a close-range acquisition, but obviously too small for an aerial acquisition. Once you've generated at least the sparse point cloud from your images, you can use the tool's control point detect markers function to attempt an automatic detection. We suggest to use the default value and move on to other presets only if the default detection fails. Also remember that you can still manually add control points normally if the detection fails for any reason. Control points can be defined over unstructured elements as well. Unstructured elements are externally generated and have no camera information, for example, a point cloud generated by a laser scanner device. Using control points to pre-align elements is a vital step during registration, which will be discussed in later tutorials. Control points over unstructured elements are drawn in green color by default, while structured elements color points are drawn in red color by default. Thank you for watching, and don't forget to join our Facebook group 3D Flow Academy in order to vote for the next tutorial.